Hello students, welcome to previous curriculum. In the next bit, in the exercise 1.4, in the next exercise is 1.4, prove that the following are irrational. So, 1 by root 2. We have to prove that it is an irrational number. So, let us assume 1 by root 2 is rational number. So, in order to prove that it is irrational, first we just assume that it is rational number. If it is rational, then there exist two integers. How we know how the rational number will be? It will be like either p by q form or q a by b. It might be anything. So if it is rational, then there exists two integers a comma b. That means 1 by root 2 is equals to a by b. A comma b are co-primes. A comma b belongs to z. That means integers. Z represent integers, right? And b not equals to 0. B is equals to 0. What happens? It becomes infinity. 1 by root 2 we have written as root 2 by 1 is equals to b by a. If a by b is rational number, b by a also will become a rational number. They are just reversing it. So b is equals to root 2 into a. If we apply squaring on both sides, b square is equals to root 2a whole square. That is b square is equals to root and square gets cancelled and 2a square. Let us assume that this is equation 1. B square is equals to 2a square is equation 1. So b square by 2 is equals to a square. If we send 2 this side, then it becomes b square by 2 is equals to a square. From theorem, if 2 divides b square, then 2 divides b. If 2 divides b square, then 2 also divides b. There is a theorem in your textbook. So b by 2 is equals to c by 1. b is equals to 2c. Squaring on both sides. B square is equals to 2c whole square. B square is equals to 4c square. Let us assume that it is equation 2. That means there also we got in the first equation also we got b square, and in second equation also we got equating 1 and 2. 2a square is equals to 4c square. A square is equals to 2c square. A square by 2 is equals to c square. From theorem, 2 divides a square, then 2 also divides a. This is from theorem. Both a and b have common factor as 2. If a and b are co-primes, this contradicts that fact that 1 by root 2 is rational number. We assume that a comma b are the co-primes. But if 2 is the factor for a and b, then how come it becomes co-prime? So it doesn't become that possibility will never occur. So that means our assumption is wrong. This is contradicting that what we have assumed. Okay, second bit is root 3 plus root 5. Let us assume root 3 plus root 5 is rational. Let root 3 plus root 5 is equals to a by b, where a comma b are integers and b not equals to 0. Root 3 is equals to a minus b minus root 5 plus root 5 becomes minus root 5 when it goes to the right hand side. If we do squaring on both sides, root 3 whole square is equals to a by b minus root 5 whole square. So this square and root gets cancelled, and this is in the form of a minus b whole square. What is the formula for a minus b whole square? A square minus 2ab plus b square. So a square means a by b whole square, which can also be written as a square by b square minus 2 into a by b. 2a by b. 2ab, sorry, 2ab. 2a is a by b and b is root 5 plus b square, that is 5 square into root 5 whole square is 5. So if we send the minus 2a by b root 5 to the left hand side, a square minus b square plus 5 minus 3. 2a by b root 5 is equals to a square minus b square plus 5 minus 3 is 2. So if we do the LCM for a square by b square plus 2, a square plus 2b square by b square, it is just a cross multiplication. So 2a root 5 by b is equals to a square plus 2b square by b square. In this side, left side 1b gets cancelled and right side 1b gets cancelled. What is left out is root 5 is equals to a square plus 2b square by 2a will come down on the right hand side. This contradicts the fact that the root 5 is irrational, because we already know that root 5 is a rational number. But what are we doing? We are equating to a rational number. A square plus 2b square by 2ab is a rational number, but root 5 is a irrational number. This is contradicting this is contradicting our assumption. That means we can say that root 5 plus root 3, root 3 plus root 5, anything, both are same, is rational number. So sum of two irrational numbers is also an irrational. We can conclude that sum of two irrational numbers will also become an irrational number. The next bit is, let us assume x6 plus root 2. Let us assume that 6 plus root 2 is rational number. 6 plus root 2 is equals to p by q form. We can assume any three, like a by b or p by q, or any two integers. Anything we can take. So 6 plus 2 root 2 is equals to p by q. P by q belongs to what? Integers. Q not equals to 0. And we are assuming that p comma q are co-primes. So root 2 is equals to p by q minus 6. Root 2 is equals to p minus 6q by q. We already know that root 2 is a irrational number, but we are equating it to rational number, and which is contradicting the fact that root 2 is rational. Root 2 is irrational. Sorry, it is not rational, it is irrational. Root 2 is irrational number. So we can say that 6 plus root 2 is irrational number. Root 5. Here, root 5, root 3, root 2. We might get one question from root 2, root 3, root 5. Or we might get a question like root 3 plus root 5. Or we might get a question for root 2, root 3 plus root 3. These were the important sums which might repeat in the examination. So please practice this one at least twice or thrice. So you'll attempt this question for sure in the examination. Let us assume that root 5 is rational number. Root 5 is equals to a by b. A comma b are co-primes. A comma b are co-primes. A comma b belongs to z. B not equals to 0. A is equals to varying on both sides. Same as root 2, same as root 3. So a square is equals to b into root 5 whole square. A square is equals to 5b square. A square by 5 is equals to b square. If we check this is, if 5 divides a square, then 5 also divides a. A by 5 is equals to 6. A by 5 is equals to c. Let us assume that a by 5 is equals to c. A is equals to 5c. A square is equals to 5c whole square. A square is equals to 25c square. From both 1 and 2, a square is equals to what you can say? B square, 5b square, or 5c square. Here a square is same, so it will be 25. Sorry, it is 25c square and 5b square. 5 5s are 25. B square is equals to 5c square. B square by 5 is equals to c square. So from theorem 1.61, we can say if 5 divides b square, then 5 all both a and b have common factor 5. But what we have assumed, a and b are co-prime. If it is a co-prime, how can we say that we have a common factor? That possibility will never happen. So we can say that this contradicts the fact that root 5 is rational number. Hence, root 5 is irrational number. By the above contradiction, we can say that root 5 is irrational number. Next, coming to the fifth bit, 3 plus root 5. Let us assume that 3 plus root 5 is rational number first. 3 plus root 5 is equals to a by b. A comma b are integers and b not equals to 0. 2 root 5 is equals to a by b minus 3. root 2 root 5 is equals to a minus 3b by b. Root 5 is equals to a minus 3b by 2b. We already know that root 5 is not a rational number. A minus 3b by 2b is rational number. But so this contradicts the fact that 3 plus 2 root 5 is rational number. So because since root 5 is irrational, this contradiction arises because we assume that in a wrong way. So 3 plus 2 root 5 is second question. This is also an important question. So this might come in the examination. So please practice. Is irrational where p comma q are primes. Let us assume root p plus root q is rational number. Root p plus root q is equals to a by b. A comma b belongs to z. B not equals to 0. Squaring on both sides. Root p plus root q whole square is equals to a by b whole square. A plus b whole square is equals to, we have the formula, right? A plus b whole square is a square plus b square plus 2ab, or a square plus 2ab plus b square. It might be. It is the same. So root p whole square plus 2 root p into root 2 plus root 2 whole square. A square by b square. B square is equals to 2 root p into root q plus q square is equals to a square by b square. 2 root p root q is equals to a square by b square minus p square minus q square. 2 root p into root q is equals to a square minus p square q square minus p square q square by b square. So root p into root q is equals to, the 2 comes in the right hand side, it becomes division. So a square minus b square p square minus p square q square by 2 square. Root pq is equals to a square minus b square p square minus b square q square by 2b square. If we say this is a rational number, the same as above. If you understand one sum properly, you can able to do any number of sums like this. So please understand the sum properly. Practice at least twice or thrice so that you will remember properly. But we know root p is irrational. This contradicts the fact that root p plus root q is rational. So root p plus root q is irrational number. Thank you.